Welcome back, students, to another lecture of fault analysis. So today we'll be discussing about line to line fault. We already have discussed about single line to ground fault, LG fault. So today we'll be dealing with double line to only double line. Okay, only double line fault. What do you mean by double line fault? Okay, so double line fault means when there is a fault between two lines. Okay, the lines can be anything. So we are mainly dealing with three-phase system having the phases as A, B and C. So in this three-phase system, default is occurring between any two lines, either AB or BC or AC. Okay, so you consider this. You see, this is the diagram of a double line fault. So this is a phase A. Okay, this is phase A, this is phase B, and this is phase C. All right, phase A, phase B and phase C. A, B and C. Okay, three lines have three impedances. This is the neutral. Now say here a fault occur between B and C. Okay, let us consider a fault occur between B and C. Before the fault occur, okay, before any fault, IA, IB and IC are equal. You see, before fault, IA, IB and IC are equal. That is VA, VB and VC. That is voltage A, voltage V and voltage C are balanced. Now after fault, where the fault occurs between two lines, line to line. Okay, between two lines, that is B and C. The fault is occurring between B and C. Okay, so whenever there is a fault, that means the path becomes, what is the path? This Z will become 0, least impedance path. Okay, least resistance path. So the whole current is going to flow through this path. Okay, now you see a fault occur between phase B and phase C. So after fault, what happens? You see IB. Okay, the current is going to flow through this path. The current is going to flow. Let me write with blue pen. Okay, yeah, the current is going to flow through this path. Okay, through this path it will come. So here actually what current is flowing? Here IB was flowing and here IC was flowing. Okay, now this IB and IC is equal to what? Fault current. Now see, when this is connected, okay, that means a fault occur between these two. So let the path for the fault be ZF. Okay, ZF be the fault impedance. Okay, now see, IB is flowing like this and IC is flowing like this. That means what? That means IB is equal to minus of IC. You see the path. Okay, if I consider a node, so here IB is coming, here IB is coming. So IB plus IC equal to 0. Okay, IB plus IC equal to 0. That means IB is equal to minus IC. Is this step clear? All right. So here after fault, IB equal to, see, IB is equal to IF equal to minus IC. Why I have written minus IC? I hope now it is clear, because the current direction, you see, this is a current direction here, this is another current direction. Okay, so here current is flowing like this, here current is flowing like this. So they are opposite to each other. That is why IB is equal to minus IC. And what is the current? IF. So this is equal to IF. Okay, IF is the fault current. And what is the current flowing through IA? Current flowing through IA is 0. Why? Because a fault occur here. So only whatever current is there, the current will pass through least impedance part. And which is least impedance part? This is least impedance part. Okay, so all the current is going to pass through this. I hope it is clear. Okay, now see, we know IA0, IA1, IA2, these are what? 0, positive and negative sequence current. Okay, symmetric current, we know it is equal to 1 by 3 A of this line currents. Okay, IA, IB and IC. With this we have already derived. Okay, now what is IA? IA is 0. IA is 0. IB is IB only and IC is minus IB. Okay, so IA is 0, IB is IB only, IC is minus IB. We got this. So here, and 1 by 3, and this is A. Is it clear? Now if you simplify, the value of zero sequence current IA naught. Okay, just matrix multiplication. IA naught 1 by 3 of this into this, row into column. Okay, so what you will get? You will get IA naught is equal to 0. Okay, this row into this column, that means 1 into 0 plus 1 into IB plus 1 into minus IB. So IB minus IB is 0. So remember, this point is very important. Okay, you should note it down. Okay, in double line fault, zero sequence current does not flow. Okay, so remember, in a double line fault, only double line, there is no zero sequence current. Okay, now let us see what is positive sequence and what is negative sequence current. Positive sequence, IA1 equal to 1 by 3 times of 1 into 0 plus alpha into IB plus alpha square into minus IB. So 1 into 0 is 0, 1 by 3 alpha into IB minus alpha square of IB. So if you simplify this, if you take alpha common, IB common, then alpha minus alpha square. We know 1 plus alpha square equal to 0. Okay, so what we need actually, alpha minus alpha square equal to what? We'll not relate this. We know alpha equal to 1 angle 120 degree and alpha square equal to 1 angle 240 degree, isn't it? Now alpha minus alpha square. So in place of IB, what will write? IB means what? The fault current. IB is equal to, this is equal to IF. IB minus IC equal to IF. So fault current, in place of IB I am writing here IF, and in place of alpha I am writing 1 angle 20 and alpha square 1 angle 240. If you simplify this, that is 1 magnitude angle 120 minus 1 magnitude angle 240. If you subtract, you do this in calculator, you will get 1 by 3 will remain 1 by 3 only, root 3 times of J. Okay, root 3 times of some imaginary number into IF. Okay, this is the answer. So IA1 how much will get? You see, IA1 how much we got? IA1 we got 1 by 3 times of root 3 J IF. Okay, now objective is to calculate I fault current. So fault current equal to root 3 by root 3 is 1 by root 3 into, if I shift this to left hand side, root 3 IA1 by J. Okay, equal to minus of root 3 IA, and here J is going to come. Is it clear? This J, I need what? IF, and IA1 equal to 1 by 3 root 3 J IF. So IF equal to 3 will go there, 3 times of IA1 divided by root 3 J, 1 by J. So 1 by J is minus J, isn't it? So I got this. So fault current, remember, is equal to minus J root 3 IA1. Okay, magnitude wise, if you calculate the magnitude, then you need not consider this J. Simply take the modulus. So modulus root 3 IA1. So root 3 IA1. Is it clear? So remember, fault current for double line current. Okay, for double line fault, this is the fault current. And in case of LG fault, what was the fault current? LG fault, it was 3 times of IA1, isn't it? Last class we have done. You see, fault current how much we got? 3 times of IA0, or IA1 or IA2. Here IA1, IA0 and IA2 are equal, but in case of double line fault, IA0 is 0. IA0 is 0. Only positive sequence and negative sequence currents are there. Is it clear? Okay. Next. Now IA2. Simplify. Simple. IA2 is how much? IA2 is 1 by 3 times of 1 into 0 plus alpha square into IB plus alpha into minus IB. If you simplify, you will get this. Okay, alpha square is 1 angle 240 minus alpha is 1 angle 120. Here we are getting alpha square minus alpha, but in case of IA1, that is positive sequence current, we got alpha minus alpha square. Okay, so in that case we got some other value, and here we got some other value. So IA2 is negative sequence current. But how much we got? Minus IA1. Okay, so remember this. So negative sequence current and positive sequence currents are opposite to each other. Okay, if negative sequence is flowing like this, positive should flow like this. So IA1 and IA2. Okay, that means they are meeting at a point. This is the meaning of this. Okay, now let us calculate the voltages. We have calculated the currents. Now let us calculate the voltages. Now voltage is how much? So current is flowing like this. Let me erase this one. Now see, this is the voltage B, VB, and this is voltage VC. Okay, now what is the voltage difference? VB minus VC. Current is flowing like this. Okay, IF is flowing like this. So this is higher potential, this is lower potential. So VB minus VC equal to how much? VB minus VC into IF into ZF. V equal to RI, that means. Okay, so VB minus VC equal to IF into ZF. VB, if I divide into positive, negative and zero sequence, VA0 plus alpha VA1 plus alpha square VA2, and VC VA0 plus alpha square VA1 plus alpha VA2. This we have already discussed in the previous lectures. Okay, let us go through this. So this we have split into 0, positive and negative, and this also we have split into 0, positive and negative sequence. Okay, which is equal to IF into ZF. Okay, now this and this will get cancelled. Okay, and if you simplify, you will get IA1 minus IA2 equal to IA1 ZF. Okay, after simplification, you will get this. Why we are calculating all this? So that we can make the diagram. Okay, now see the diagram. So diagram of for double L fault. Okay, now here we don't have any zero sequence, we have positive and negative. So how do we represent a positive sequence? We represent a positive sequence by a generator and a impedance. This is positive sequence. Okay, EA1, this is Z1. Okay, now we have a, this is Z2. Z2 means what? Negative sequence. It do not have any source. This positive sequence has got a source, but this negative sequence do not have any source. Okay, now here we connect one fault impedance ZF. Okay, now we'll connect this. Now what current was flowing? Here what current was flowing? Here IA1 current is flowing, isn't it? Positive sequence current is flowing, IA1. And here what current is flowing? Negative sequence, IA2. They are meeting somewhere. Suppose they are meeting at this point. So IA1 plus IA2 equal to 0. IA1 equal to minus IA2. This only we got. IA1 and IA2 should be negative of each other. So your connection should be like this. Okay, series in series, but these two are equal. So currents are in series but opposite direction. That is why I have given like this. In the LG fault, what was the case? IA1 equal to IA2 equal to IA0. There zero sequence current is also there, but here zero sequence current is missing. So remember this point. Okay, now voltage. So I've already mentioned. Okay, so this is VA1. Alright, and this is VA2. Negative sequence voltage, positive sequence voltage. Is it clear? So this is the diagram. This is connected. Okay, so from here what I can calculate? IA1 I can calculate. How much is IA1? How much is IA1? So IA1 is one source is there, E divided by how many source impedances? Z1 plus Z2 plus ZF. So 3. So IA1 or minus IA2. Okay, equal to IF. Okay, now see we are dealing with three phase. So this is in per unit. Okay, this everything we have calculated in per unit, PU, because this we have considered as PU, this also PU, this also PU, and this also PU. Now IF equal to root 3 times of IA1. We have got this now. How much is IF? You see, IF is root 3 times of IA1. IF is root 3 times of IA1. Okay, sorry, it is not, it won't be IF. IF is equal to root 3 times of the magnitude I am written. J part I am not writing. That is why root 3 times of IA1. IA1 is how much? EA1 by Z1 plus Z2 plus ZF. So we got this. So finally fault current we got this. Okay, fault current we got this. So try to compare double LG with LG. Okay, now in terms of power unit, now in terms of actual unit, actual equal to power unit into MVA by root 3 VL. Okay, this is the formula. Same for LG also, IF into MVA by root, it is PU equal to actual by base kV square by MVA into actual. This MVA will go in the numerator, so MVA by kV square into actual. So MVA by kV square into actual, MVA by kV square into actual. Okay, so this is the thing. So there are various methods of calculating short circuit MVA. Okay, short circuit MVA, that is MVA means what? Power, volt ampere. Okay, short circuit MVA, this is one method, EV minus EC into fault current, or directly power unit of EA1 into power unit of IA1, or root 3 times of E phase into IF voltage. Okay, so these are the processes of calculating short circuit MVA if they are asked short circuit. Okay, but until here you remember, that would be good. Okay, up till here derivation also comes in exam. Okay, I hope it is clear, the derivation is clear to all, isn't it? Okay, now let us solve one numerical based on the theory whatever we have discussed. Simple numerical. So line to line fault, one numerical like the previous numerical only. 100 MVA, 11 kV, positive sequence, negative sequence and zero sequence, 3 are equal, that is 0.1 per unit, and ZF or Zn is equal to 0.05 per unit. Okay, so this is given, the impedances are given, the power rating is given, the voltage rating is given. Now line to line fault occur between B and C. Okay, between B and C line to line fault occur, same like the diagram. Now we know what is been asked, find IF, fault current in per unit. Okay, per unit they are asking. So we know IF equal to root 3 times of EA1 by Z1 plus Z2 plus ZF. Just now we have derived this one, IF equal to root 3 EA1 Z1 plus Z2 plus ZF. You see, so that only we have used here. Okay, so root 3 into EA1 in per unit. EA1 is how much? Always 1 per unit. Always voltage source we should consider is 1 if you are calculating per unit. So EA1 equal to 1, Z1, Z2, ZF 0.1, so I have written here 0.1, ZF is 0.05, so 0.05. If you calculate you will get 6.92 per unit. Okay, but they want first value is per unit only, second part fault current in ampere. So per unit value into MVA divided by root 3 times of kV square, isn't it, or kV square VL, root 3 times of VL. Okay, it is in 3 phase, it is why it is the formula. So we know this, see, so remember this formula, MVA by root 3 VL. So 6.92 into MVA by root 3 VL. If you put here MVA you know 100 and VL is 11 into 10 to the power 3, that is it was given in kV, 11 kV. So we got 36.320 kilo ampere. Okay, second part over. Third part, short circuit MVA. Short circuit MVA we have various methods, anyone you apply short circuit MVA. First method is root 3 E into IF ampere. Okay, this E is phase, this is phase voltage. Okay, root 3 E, phase is whatever voltage divided by root 3 is phase voltage into IF in ampere. So this is one method. Another method, how much we got by this method? 400. By all method we should get the same result only. Next is short circuit MVA per unit is EA1 per unit into IA1 per unit. EA1 per unit is 1, we know, because in per unit whenever you consider voltage which is considered as 1. IA1 per unit, IA1 is how much? This is also 1 by Z1 plus Z2 plus ZF 0.1, 0.1, 0.05. If you calculate you will get 4 per unit, but actual we want in MVA. So this per unit value into actual value, so into base value. Okay, base, so base is how much? This PU equal to actual by base. I need actual, PU into base, which is 100. 4 into 100, how much? 400 MVA. Same as this. Okay. And third method is 3 times of EA1 plus IA1 ampere. So this is in volts, obviously per unit, PU, not per unit, per phase, okay. So 3 into 11 into 10 to the power 3 by root 3 per phase into IA1. IA1 is how much we got? This, okay, this one. We put this value, this value only. This value in per unit is this value, actual value is 36.320. So instead of writing this, I have written 6.92. that means per unit into base. Okay, so finally we got this 400 MVA. I hope it is clear. Okay, the problem was very simple. It is totally based on the theory. Okay, so theory should be very clear. Okay, so go through it. I hope you have understood the lecture. If you have any doubt, you please comment. Okay, next I'll be moving to another topic, that is double LG fault. That will be in the next lecture. All right, thank you.